Well, good morning, everyone, and welcome to an AIHI seminar. This is in the seminar series of the Australian Institute of Health Innovation. And incredibly fortuitously, we've got Professor Lesley Hughes talking about how worried should we be about climate change the day after the intergovernment report on climate change came out yesterday, the 6th assessment report. So let me say a few words first. Professor Hughes doesn't need any introduction in reality. She's on TV and the media very frequently talking about climate issues. She's a distinguished professor at Macquarie University, but to be frank, she's one of my heroes, and she is out there on the front lines explaining about the importance of us mitigating and dealing with climate change every day. So it's a real treat to have you, Lesley, and allow me please to say a few words and run through a few slides just to give the audience some context before we hear you talk. A bit about the Institute. We do health systems research. We're very interested in human health and the systems that improve healthcare for patients, whether that's policy or practice on the ground or behavior change. And that's where you can find more information about us if you're not from the Institute. Our mission is to heal, learn, discover, and we spend a lot of time in discovery. We get a lot of grants, National Health and Medical Research grants to support our work. We have 3 university centres as part of the Faculty of Medicine, Health and Human Sciences at Macquarie. And these are the 3 leads of each of the centres. And around those 3 university centres, we have National Health and Medical Research Council and other grants to support our work. First things first, the Intergovernmental Panel on Climate Change, the IPCC, is a UN body. It's a very authoritative body, and Lesley's going to explain a bit about that. And its job is assessing the science related to climate change. So this is about the science of climate change. We will talk a bit more about the politics of climate change for sure, but the starting point is, what does the science say? So the 6th assessment report was released yesterday. The ink is still wet, fresh on this. And if you want to join the discussion, here's how you do so: social media or the hashtags if you're at Twitter. The key message is very simple for me. I've had a chance to scan through the voluminous 6th assessment report since yesterday. Climate change is widespread, rapid, and intensifying, and you can't get away from that. That's as of yesterday from the IPCC. Here's just some of the data and the reports that this 6th assessment compendium of information has produced in one snapshot slide. It shows the first graph that human intervention in the environment is, you can attribute a lot of what's happening in terms of the warming climate to human intervention. This is what happens if it's business as usual in terms of CO2 emissions, and you don't have to be a scientist actually to know that's not good. If there was warming by 2100 to 2 degrees, there would be 10 centimeters more ocean rise. That doesn't sound like much. What's 10 centimeters? That would be cataclysmically bad for many, many countries. And here are some of the feed-in reports from the IPCC 6th assessment. Lesley, I said, has been out on the hustings. She's not just a distinguished professor from a research point of view, but she is an activist. I think, can I use that word, Lesley? And this is one of the quotes directly. I'm sure you're going to get embarrassed, Professor Hughes, by me quoting you, but there must be no new oil, coal or gas exploration or infrastructure. We have to stop subsidizing fossil fuels. Everything needs to be electrified and renewables. We just have to change. What are the sustainable solutions, though? It's fine, academics saying the science says this is bad, But what about sustainable solutions? The best source I know, I'm sure Lesley knows more and better ones, but was the Lancet Commission in 2016, which said we have to do 10 things. We have to invest in climate change and public health. We've got to scale up financing. We've got to protect people's cardiovascular and respiratory health right across the world. There's 8 billion of us will be affected by this and are being affected by this. We've got to encourage a transition to healthy lifestyles. We need international carbon pricing mechanism, and countries have to have carbon pricing. We need renewable energy, not just in the high-income countries, but in low and middle-income countries. We need to mitigate the effects of climate change. We need to facilitate collaboration. This is an intersectoral government problem, not just the Ministry for Health or the Ministry for Environment. We need an international set of agreements, and that's what is going to happen, we hope, in Glasgow in November, which is where the IPCC report and Lesley's talk points to. And finally, we need a countdown to 2030 where we're really tackling what we know we need to tackle. That's all I want to say. I'm just the warm-up person for the main speaker. Lesley, I'm going to stop sharing shortly, and over to you. Here's a wave from the people in the Institute, every one of whom unequivocally supports Lesley Hughes and her work. Lesley, you are, as I said, one of our heroes. You're one of my heroes. Please, if you could address us, I will stop sharing to enable you to share.
Thank you so much, Jeffrey, and thank you, everybody. I see we have 90 people online, which is amazing. I will begin to share my screen now. And I hope everybody can see a scary picture of a bushfire. Okay, well, with no further ado, I've got a lot of slides, but I'll go fairly quickly and hopefully there'll be plenty of time for questions and discussion at the end. So this is what I want to cover today very briefly. The climate we've had, the climate we'll get very likely, both globally and in Australia. What some of the impacts that we've had and will likely get in the future. And I will emphasize health impacts because of this particular audience. I want to talk about the probability of alternate futures. And of course, finally, what is the solution? What do we have to do? Well, you'll all be aware that, of course, that atmospheric CO2 is going up. We're now at nearly 50% above the concentration that we had in pre-industrial times. And the IPCC report that Jeffrey just mentioned says that this is higher than at any time in at least 2 million years. I'm going to show you this little graphic now, a little animation that will show you what's been happening to global temperatures for every country in the world. They're arrayed in alphabetical order, so Australia's up in the middle of the top line. And it'll show you the temperature anomaly, that is whether individual years are cooler or warmer than average, with the cool years in cool colours and the hotter years in hot colours. It'll take the data right through to 2018, and then it will show you some projections out to the end of this century. If you'll forgive the pun, it'll take a few seconds to warm up, but then I think you'll see very clearly what's been going on. Here we go. So that's all real data. And now we have the projected data every decade out to the end of this century. And the main message, of course, is that it's been getting very hot, and it doesn't matter where you are in the world, it will continue to get hotter. I'm going to draw on several reports in this talk, one of which was the NASA report that came out last June that showed that the amount of heat trapped near the Earth's surface has doubled since just 2005, with the Earth warming faster than expected. I'll also draw on the Climate Council's latest report, Aim High, Go Fast, and I'm a councillor with the Climate Council, and as full disclosure, I'm a co-author on this report. And as Jeffrey said, the IPCC 6th Assessment Working Group 1 report that was released officially at 6 p.m. last night. This is a graph from the IPCC report. I'm not going to show you very many graphs, just a couple, but this is a really important one. It shows the reconstructed temperatures going back 1,000 or so years, and then the observed temperature of what we've been getting in the last couple of centuries to decades. Don't let anybody tell you that what we're experiencing now is natural variation, because it is far from natural. Looking ahead, and this is the graph from the Climate Council report, because we know that global average temperature is accelerating and we know what the current rate is, it's about 0.24 of a degree every 5 years, we can extrapolate to the near term very confidently to 2025 and 2030, as is shown on this graph. And you will notice that the temperature by 2030 exceeds 1.6 degrees. And I'll come back when I talk about the Paris Climate Agreement as to the significance of that number. So here's just a few of the things that's been going on. Glaciers are retreating and will continue to do so for decades and probably hundreds of years until they're basically gone, many of them at least. The IPCC states that the rate of ice sheet loss in the Arctic and Antarctic has increased fourfold in the period comparing in the 90s compared to the last decade. The water cycle is intensifying. That is, dry areas are getting drier, wet areas are getting wetter. More regions are being affected by drought. And in Australia, the IPCC says that the rainfall patterns that are related to the El Nino Southern Oscillation, which is one of the major phenomena that affect weather in the eastern part of Australia in particular, will be amplified by the second half of this century. And what that means is that in El Nino periods where we get drought, we'll get more drought. In La Nina periods where we get wetter conditions, we will be getting a lot more floods. We've just seen in Germany and other parts of Europe, for example, some of the impacts of catastrophic and unprecedented flooding. Cyclone intensity is increasing, though not frequency. There is now serious talk of the need for a Category 6 because Category 3s, 4s and 5s are not going to be adequate for cyclones of the future. Extreme heat and heat waves are also increasing. 2020, for example, was globally the hottest year on record, with the previous 7 years being the 7 hottest on record. We've seen the impacts of that most recently in North America, where temperatures in parts of British Columbia got up to nearly 50 degrees, extensive wildfires, about 500 deaths, and it's been estimated that this specific event was at least 150 times more likely because of climate change. Also, it's been estimated that an event like this, which we might consider would only occur once in every 1,000 or so years, would occur every 5 to 10 years with 2 degrees of warming. I'll talk a bit more about 2 degrees later on. Our oceans are doing us on land a great favour because they're absorbing over 90% of the excess heat in the Earth system. But this means that warming is now detectable down to a depth of 2 kilometres. The oceans are also absorbing much of the extra CO2 in the atmosphere, but that's changing the composition of seawater such that our oceans are now 30% more acid on average than in pre-industrial times. And this is already having an impact on marine life. Because of glacier melt and ice sheet melt, and because Warm water occupies more space. It's less dense and occupies more volume than cool water. Our rate of sea level rise is also accelerating. It was twice the rate in the period from 2006 to 2018 compared to the 70s up until 2006. Sea levels we know will continue to rise over this century regardless of emissions, maybe up to about 1 metre of sea level rise under a high emissions scenario by the end of the century. And sea level rise is actually going to be irreversible on the scale of potentially up to thousands of years. It's a slowly moving system and it's very difficult to turn it around. At 2 degrees, sea levels could rise up to 6 metres. At 5 degrees, an unthinkable amount, we're looking at 19 to 22 metres. In some locations, what these extreme sea level rises mean is that when we get a storm surge that might have occurred previously only once in 100 years, we could get that same impact at least annually by the end of this century. One of the things that the IPCC report warns about is that the world is becoming closer to catastrophic tipping points. Here are some of the tipping points that should worry all of us. So if I go around in a clockwise direction from the upper left-hand side, the conversion of rainforest, particularly in the Amazon, from being a sink for carbon dioxide to being a source for carbon dioxide is already occurring, helped along, of course, by other human impacts in the Amazon, such as clearing and burning. The top right hand shows the permafrost. The permafrost in Siberia is currently on fire. And when that happens, we get a huge amount of positive feedbacks to the climate because all of that carbon trapped in frozen permafrost is released into the atmosphere. It's an example of a very worrying positive feedback. As I indicated before, coming around on the bottom row, glacier loss. Glaciers are not only just pretty to look at, they're actually a reservoir of water for about 1/6 of the world's population. When the glaciers are all gone, that dam of water that so many billions of people use will also be gone. Coral reefs, at 2 degrees of warming, it's been estimated that most of the world's coral reefs will be gone. And as I mentioned before, the complete loss of summer Arctic sea ice is potentially another tipping point. So what's happening in Australia? Well, Australia, of course, also heats up like the rest of the world. In fact, by the end of last year, Australia had already warmed 1.44 degrees since records began in 1910. It's the case that over the past 5 years, when we look at modelling projections, Australia tends to be at the upper part of those projections, as you can see here from this graph. But it's not the average years that we worry about, of course, it's the extreme years where impacts are felt more prominently. And of course, we're getting more and more of those. But for example, it's been extreme warm years where marine heat waves have caused 3 bleaching events in the Great Barrier Reef just in the last 5 years, which has resulted in about 50% of the coral being lost. Here's some Australian statistics. Our warmest year on record was 2019. As I said, we've warmed 1.44 degrees. In 2019, we had 3 times the number of extreme hot days as we had in any year from the last century. And poor old Penrith was actually the hottest place on earth at 48.9 degrees in the summer of January 2020. Our rainfall is also changing. Parts of Australia are getting wetter, such as the northwest, the greeny parts of this map, but a lot of Australia is getting drier, and that's the browny part. So the southwest and basically the eastern half of the country has been getting drier over the last few decades. 2019 was our driest year on record, with rainfall about 40% below the average. And this is contributing to an increase in the Forest Fire Danger Index, which is the index used by emergency services on a daily basis to assess fire risk. And you can see the browny parts of this map is where forest fire is getting more dangerous. We're also seeing major impacts in the oceans around us, with the ocean surface around Australia warming more rapidly than a lot of other parts of the world, particularly this southeast corner. It is one of the most rapidly warming parts of the global ocean. So that's a little bit about the climate we've had and the climate we might get, both globally and in Australia. But what about the impacts of all of that? And I want to just briefly talk a bit about the impact on some ecosystems, on our economy, and on our health. So the Black Summer bushfires should be still pretty fresh in most of our memories. Of course, Black Summer is a bit of a misnomer because the wildfires actually started in July, in winter, and they kept going in different parts of the country right through till it actually started to rain in late January. Overall, there were 18 million hectares of Australia burnt over that period. And to put this in perspective, that's about 3 times the size of Tasmania. Here are some of the impacts. It's been estimated that about 3 billion native animals were either killed or displaced, with many of them losing their habitat. 80% of the Blue Mountains World Heritage Area burnt, and even more significantly, 50% of our Gondwanan rainforests burnt, and rainforests do not recover very well from fire, at least not in hundreds of years. We lost 3,000 homes or more. It was actually so far the costliest climate-related event in Australia's history, and the costs are still being counted, but at last count, they were approaching $100 billion. There were over 400 excess deaths, over 4,000 increased hospital admissions, and a full third of the Australian population was affected at some point by smoke. So now for health, just a bit about health. The Lancet has a very famous quote from 2009 where they said that climate change is the biggest global health threat of the 21st century. A lot of what I'll say now comes from the Lancet countdown that Jeffrey mentioned in the introduction. This is being done regularly now, looking at 43 indicators across 5 sectors, covering impacts, exposures and vulnerabilities to climate change. There's also our own Australian version published in the Medical Journal of Australia, and I believe the link to this is in the chat. So what's the Lancet been finding? Well, here are the main messages. They find that the impacts of climate change on global health are unequal. They disproportionately affect populations that have not only contributed least to the problem, but are the least well equipped for dealing with the problem. They find that climate change interacts with other forms of social and economic inequality, exacerbating long-standing inequitable trends both within and between countries. They identified the most vulnerable groups being children, the elderly, lower socioeconomic groups, those with existing chronic disease, those people that are isolated, Indigenous communities and outdoor workers. And they identified the fact that many carbon-intensive policies and practices are synergistic because they don't just contribute to climate change, they also contribute to poor health quality, poor food quality and poor housing quality. But what this means, and I'll give an example in a moment, is that dealing with some of these sources of inequality have co-benefits for other things. So I'm just going to give 1 or 2 examples of how climate change and health interact in terms of heat, fire, food, vector-borne disease, air pollution, and a little bit on mental health. So firstly, heat. Heat and heat waves kill people. And I still think these numbers seem absolutely extraordinary. The 3-week-long heat wave in Europe in 2003 is estimated to have caused 70,000 excess deaths, and one in Russia in 2010, 56,000. This is especially extraordinary given that these deaths occurred in relatively developed countries. These are figures from the Lancet report that vulnerable populations were exposed to an additional 470 million heatwave events just in 2019. And in the past 20 years, there's been a more than 50% increase in heat-related mortality in people over 65. And this has affected GDP in terms of potential labour capacity lost, especially in developing countries subject to high heat exposure, like India and Indonesia. A really recent paper that only came out just a couple of weeks ago indicated that analysed warm season related heat deaths across 43 countries, found that 37% of those deaths can be attributed to anthropogenic climate change. They found increased mortality evident on every continent, with once again the burdens varying geographically depending on the vulnerability of those populations. Here in Australia, the frequency of extreme events is increasing a lot, as you can see from this graph, with a huge increase in 2019-2020. It's also worth considering that extreme heat and heat waves actually kill more Australians than all other weather-related events combined. That stat usually comes as a shock to people. Heat waves have been dubbed the silent killer. And the reason that we get shocked by this, of course, is that heat waves don't leave the sort of scars on the landscape that a flood or a fire does. But nonetheless, they are actually the most important climate-related killer. Looking ahead, we know from several recent studies that average days over 35 degrees in Western Sydney could increase 5-fold by 2090, with 50-degree days in a lot of the Australian capital cities, including Sydney and Melbourne, relatively common by mid-century. This paper in 2015, for example, estimated what this actually costs the Australian economy in terms of absenteeism and reduced work performance. So climate change is not just costly for infrastructure, it's also costly for human capital. This, I think, is always an interesting stat. If we think back to the Black Saturday bushfires in February 2009 in Victoria, shockingly, 173 people lost their lives over those few days. What is less well known is more than 370 deaths, so twice that number, occurred from heat-related causes in the very hot week that preceded the fires. Once again, the deaths in the Black Saturday bushfires were obvious. The deaths from extreme heat, less so. And of course, in our capital cities, we also have the urban heat island effect to contend with, because temperatures in urban centres, for a whole lot of reasons, tend to be several degrees hotter at any one day than surrounding areas. So what about fire? This picture I just downloaded last night. This is what it feels like to be in Athens right now. The Lancet showed that between 2004 between 2016 and 2019, compared to the period 2001 to 2004, 114 countries around the world experienced an increased risk of fire, with Australia having one of the largest increases. They also estimated that from 2016 to 19, this risk translated into nearly 200,000 daily exposures to wildfires every year. This is just a map that was produced last Thursday, I think it was, maybe last Wednesday, of where the fires are currently burning right across the world. a really, really extraordinary extent of wildfire. So let me move briefly to food security then. Food and health are inextricably linked. We know that as global warming continues, the yield potential of the major crops, maize, corn and rice, are declining because these crops just don't like it when it gets above 30 degrees. We've seen a decline of nearly 5.6% by 2019. World hunger was actually kind of getting better for a long time until about 2014, when it started to uptick again. And climate change and extreme weather is seen as the leading cause for world hunger starting to rise, and it's been rising in the last 3 years. Vector-borne diseases, of course, are also affected by climate, both positively and negatively, depending on the disease and the vector. But we've seen, according to the Lancet, a 15% increase in dengue fever from the 50s to 2018, with other regional increases in malaria and Vibrio bacteria. There's lots more details in the Lancet report. Air pollution. So this goes hand in hand, of course, because air pollution is largely caused by the burning of fossil fuels. And the Lancet estimates that there are about 1 million deaths per annum from pollution just from coal-fired power stations, setting aside the climate change that coal-fired power stations are causing. So pollution from coal is a huge problem on its own. And then finally, mental health. Mental health and climate change do go hand in hand as well. We know that hospital admissions for mental and behavioural disorders significantly increase in heat waves. We've also got some pretty good data here in New South Wales about the increase in suicide rates, especially amongst men in rural regions as we get rainfall declining. So drought and suicide are very, very highly correlated. But then there's also the mental health impacts of simply worrying about climate change. I'm probably contributing to these mental health impacts. This was a recent article in The Conversation from a paper that showed that Australians are actually 3 times more worried about climate change than about COVID. I thought this was a really interesting study, given that COVID, and I'll talk a bit about COVID towards the end, is sort of 110% of our media coverage at the moment. But interestingly, Australians still realise that when the COVID pandemic is under control, climate change will still be with us. But it's not all bad news. I'd like to raise some good news, some from the IPCC and some from the Lancet, particularly around growing awareness and growing action, but also the strong recognition now of co-benefits of dealing with climate change for other issues. So these are just some things that I pulled out of the Lancet countdown on the health sector. So the health sector is actually responsible for nearly 5% of global emissions, at least it was in 2017. But along with this, there is growing engagement of health professionals in both climate action, advocacy and adaptation. Health services in many countries now are strongly connected to their meteorological services to assist in adaptation planning, so things like heat wave alerts, etc. A lot of countries around the world have developed plans for health adaptation, with global spending increasing 5% just in 2018 to 19. A lot of our health institutions are also committing to divesting from fossil fuels. There was a huge push in 2018 with over $800 million divested. Some money also divested in 2019. Publishing on climate change from an academic perspective has actually increased 8 times since 2007, and that is a larger increase than publishing on climate change itself. So proportionally growing interest in the impacts of climate change on health. And overall, global coverage in the media of climate change and health in 2018 to 19 increased by 96%. So all of that, I think, is good news. And then in terms of co-benefits, and there are a huge number of co-benefits of dealing with health issues and dealing with climate change at the same time, but I'm just going to mention one that I find particularly interesting personally. So the Lancet has got some really interesting figures on the impact of red meat consumption contributing to deaths. Nearly 1 million deaths in 2017 attributed to excess red meat consumption. There was an incredibly important and detailed review published a couple of years ago in Science about the greenhouse gas emissions from all of the foods that we all consume, which came to this very stark conclusion that avoiding meat and dairy is the single biggest way to reduce your impact on the earth. So I think these two things show that dealing with one problem can help deal with another problem. And Australians really are getting on board with this. So this is a headline from just last May showing that the meat industry in Australia is shrinking as more Australians embrace plant-based diets. So where are we headed now? What are our chances? How worried should we be? Well, you'll all be aware of the Paris Climate Agreement, which has an aspiration for us all to stay below 1.5 degrees, but if we can't do that, to at least aim to stay well below 2 degrees. Unfortunately, we're not meeting those targets currently. In fact, if we add up all the pledges that countries around the world that signed up to Paris made, and if all of those pledges are met 100% and on time, we still get to pretty much 3 degrees of warming. And if you consider what's happened right now and is happening right now with about 1.2 degrees of global warming, we can only imagine what could happen at 3 degrees. This is just a little graphic showing how dangerous a lot of experts think this could get. 2 degrees being a very dangerous boundary, 3 degrees resulting in outright chaos, and 4 degrees being incompatible with an organised global community. So what do we have to do to avoid this alternate future? Well, there's a little algorithm called the carbon budget, which is proving to be a very useful predictor and a very useful guide for what we have to do. There is a roughly linear relationship between how much carbon we put into the atmosphere and how much the world warms up. And we can use this relationship to see what we need to do. So we can use the carbon budget to ask a question like this. What are the probabilities that we'll meet the 1.5 degree target? Well, current emission rates are around about 11.5 gigatons of carbon per annum. At this rate, the carbon budget calculations tell us we've got about 2.5 years of carbon left to spend into the atmosphere before we get to 1.5 degrees. So to meet this target, we would need actually a 5-fold increase and successful implementation of Paris pledges. If we ask the question, what about staying well below 2 degrees using the same calculations, we've got about 9.5 years. So roughly a decade from now to stay well below 2 degrees at the present rate of emissions. So to meet this target, we would need about a 3-fold increase in our Paris pledges and meet those pledges. So we know that to stay well below 2 degrees, we actually have to reduce our emissions globally by about half by 2030. And extrapolating beyond that, we need to get to net zero by 2040 at the latest. And the oft-cited target of net zero by 2050 is actually, according to the carbon budget, about a decade too late. How is Australia going? Well, in short, terribly. The most recent Sustainable Development Goals report from the UN looked at 165 countries and how they were meeting those goals. Australia rated about 35 overall. But when we break it down and look at each one of those 17 goals, particularly at goal number 13, which is climate action and climate policy, here's where we rated last out of 165 countries on climate action and climate policy. Last year, we were second last, ahead of Brunei. This year, we're last. The AIHI Go Fast report that we put out from the Climate Council in March actually estimates what Australia needs to do our fair share of global action. We made some calculations based on our current and past emissions, so how much we've been responsible for, our level of economic development, how feasible it is to do what we need to do compared to other countries. And what we estimated was that Australia needs to reduce emissions by 75% below 2005 levels by 2030 and to reach net zero by 2035. That 75% is about a threefold increase on our present emissions reduction targets that we took to Paris, which we're not meeting anyway. Nobody thinks this is going to be easy. It requires an immense all of society effort, but our friends at ClimateWorks have modelled a pathway showing that we can actually get there. It is a huge opportunity for Australia, especially given that we have some of the best renewable resources in the world. We have great science, a skilled workforce, and easy trade access to Asia that we could not only send our manufactured goods to, but send our renewable energy to. It is possible. Looking ahead to November, the next big climate meeting for the UN, COP26, will be in Glasgow, a hugely, probably the most important meeting since Paris. The signatories to the Paris Agreement are expected and encouraged to increase their level of ambition. Thus far, Australia has indicated none of that. Fortunately, other countries around the world, including some of our major partners and allies, are stepping up. So the EU is putting forward a 55% reduction target by 2030, the US 50%, the UK is the winner on 68%, Canada 40 to 45%, Japan 46%. Interestingly, in fact, I think the most interesting thing about the IPCC report that came out last night was this very positive statement saying that if we manage in the next few years to make rapid and deep cuts in emissions, the benefits of this action could be realised in our lifetimes, in fact, as soon as 20 years from now. It's the first time, in my view, to my knowledge, that the IPCC has actually put a time frame on which we could expect to turn things around, stabilise temperature, stabilise the climate, but it will take a great effort. Now, no talk about health would be complete without some mention of COVID. So I want to make a couple of points about COVID in relation to climate change. I'm often asked, well, has COVID been good for the climate? Is it the silver lining? And in some ways, I guess it is. These two graphs show what's happened to global fossil fuel emissions in the last year or so, presumably as a result of the COVID pandemic, slowing down economic activity, keeping planes out of the sky, and all of those other things. There has been a drop in emissions. In Australia, this is also the case with around about a 3% decline in emissions as at the quarter last year, the second quarter of last year. Of course, what we expect is that as we gradually come out of lockdowns and out of the pandemic, unfortunately, those emissions will start to rise again due to increased economic activity. But there is a really important lesson from COVID, because we know that the governments that handled COVID better, and this includes Australia at least at the beginning, not going so well right now, But the governments that handled COVID better did these three things. They listened to the experts, they acted early, and they prioritised the threat. If only all of the governments in the world had acted in exactly that same way on climate change, we would not be in the position that we're in now. So there are really important lessons. A successful handling of COVID involves the same sort of actions as a successful handling of climate change. So finally, here is the sort of mantra that I would like to leave you with. We are in a climate emergency. It's facts. It's not just a slogan. We are seeing our physical and our biological world transforming in front of our eyes. We don't have a lot of time to turn it around. And here's the real mantra. Every fraction of a degree matters, every year matters, and every choice matters. Thank you very much for your attention, and I will stop sharing and take questions if there are some. Thank you.
Just while we're waiting for that, thank you, Lesley. I applaud that fantastic talk. The title of the talk was The Worry Bit. Well, I don't think anybody listening isn't more worried than they were before you started. Now, Chrissy's going to help us. Chrissy, thank you very much for doing all the organising, and you too, Andrew. We're really deeply appreciative of all the background organising to make these happen. We're going to try and look at some of the questions, and let me take them from above. So Marjorie Bahaj says, we need to train and drill citizens on survival of extreme weather. Japan is using virtual reality for scenarios. Can we link up and develop our survival techniques? I guess I would say, Lesley, you'd hope that we do the fraction of degrees to equal mitigation, and we don't have to do survival of the entire species. But do you have a comment on that?
Yes, look, because even if we get emissions, even if we stopped emitting carbon dioxide today, we'll still get a decade or two of climate impacts. So at the same time as reducing emissions and mitigating climate change, we also need to learn better to adapt to what's coming in front of us now and what's coming to us in the next few decades. So adaptation and mitigation, it's not one or the other, it's got to go hand in hand. Unfortunately, in Australia, we're pretty good at mopping up after disasters and really bad at preparing for them. So it's the Productivity Commission a couple of years ago estimated that we spend 95% of disaster-related funds on mopping up afterwards and only 5% of preparing beforehand. So I think if we turned that around, we would be in a much better shape to be coping with what's coming ahead.
A quick one, a technical question coming in from Anne Lawless, Dr. Anne Lawless. Do we have projections of effects on the Indian Ocean dipole and the Southern Ocean?
Anne, I think we do. It's in the report. Unfortunately, because the report only came out last night and it is over 1,000 pages long, and just the summary is about 100 pages long, I can't tell you what's in it specifically about the Indian Ocean dipole. I know is saying that the Southern Ocean is warming up more rapidly than other parts of the world, but I can't give you any more details than that. There is, however, in the report and this is new for the IPCC, an interactive atlas, so you can sort of identify a part of the world and hit a button and it will tell you what's going on and what the projections are. So I hope there's something in there for you.
Quick question here. It's more a statement from Anina Rich. There's a campaign running to push UniSuper to divest from fossil fuels because our superannuation fund currently has investments in fossil fuels. I think many other people have put huge pressure through that campaign on UniSuper, and we should continue to do that.
Yep,
and
I absolutely agree. We've got to keep doing that. UniSuper is moving in the right direction, but I think we would all agree that they haven't moved nearly far enough. So let's keep that pressure up. They're using our money after all.
Yeah, yeah, and it's our future. It's our superannuation. So John Gillespie says, I've read one estimate that agriculture may be responsible for about 50% of greenhouse gases, more than the fossil fuel industry. But we constantly hear in the media about fossil fuels. Why not more about agriculture? And you made the case, Lesley, and there's a bigger case to be made, I think, for less red meat and less dairy and more plant-based, which many of us, of course, are moving to more plant-based diets. Do you have a comment?
Yes, look, the estimates of 50% of greenhouse gases are only made if you include, I believe, things like transport and fertilizer production, which is from fossil fuels. So it depends on how you do the estimates as to where those bits of the pie get counted. The more common estimate is usually around 20% of greenhouse gases are coming from agriculture, but an enormous proportion of that is from livestock agriculture, but it does count fertilizer, etc. So it depends on how you cut the pie. But over and above that, it is certainly the case that, as I mentioned in the talk, giving up on meat and dairy, and I confess I'm not a vegan. I'd sort of like to be able to be a vegan, but I haven't quite got there yet. I've certainly cut down on my own meat and dairy consumption. I think there's some really interesting, and I've written a bit about this with the dairy industry in particular, there's some really interesting developing technologies in terms of synthetic meat and synthetic milk, using yeast and synthetic biology. They're really taking off, and I actually think they have tremendous promise in getting on top of some of these things.
Thank you, Lesley. A couple of other questions coming in. One's from Monica Janda. Thanks very much. What can individuals do? Can we plant more trees, change to public transport, cycling rather than being in a car? The kind of individual things that we can do to help.
Yes, look, climate change is such a big and complex problem. We have to tackle it at all levels, from individual to international. And there are things, of course, we can all do individually, you know, use our cars less. You know, I've just had taken a big swallow and bought an electric vehicle, which are quite expensive still in Australia, but I now charge my car from my solar panels on my roof and get a bit of a kick out of that. Certainly, storing carbon in soils and vegetation is very important, and it's another example of a co-benefit, in this case for biodiversity. So planting new trees, absolutely. One of the other hats I wear is as a director of WWF-Australia, and we've just got a new big campaign. You might have seen some of the ads called Regenerate Australia, which is about raising money for restoring trees in the landscape. Obviously, this needs to be done sensibly because depending on where you plant trees, you can use up a lot of water or you can create more fire risk, etc., etc. But it is also, of course, part of the solution. And yes, stopping clearing is an enormous part of the solution before we turn it around. There's no point just planting new trees if somebody down the road is knocking them down again. We need to do all of those things.
Thank you. A quick question from Kayleen Smith, who's been interested in ecosystem and the environment for many years. Do you think we should focus on methane emissions?
We maybe not focus on it, but certainly we need to concentrate on it at, you know, probably almost as much as CO2. So methane is a short-lived greenhouse gas, but molecule for molecule, it's a more effective heat trapping gas even than CO2. Methane is measured in parts per billion, whereas CO2 is measured in parts per million. But methane is also going up. So once again, getting our livestock, red meat livestock under control would help with methane. But we do also produce methane from things like industrial processes and also indeed from rice paddies. So getting the agriculture sector to net zero is the hardest sector of all. The agriculture sector will probably always be producing greenhouse gases, why if we get to net zero, it will be by getting to below zero in some of the other sectors. but still allowing some of our agriculture to emit greenhouse gases. But yes, methane is absolutely part of the issue.
Lesley, a couple of questions have come in about the politics of this, and I know you never shy away from that. In fact, that's one of the things I absolutely admire of your approach, which is to take the science and take a talk like this, but also speak truth to power. Alex Barrett, of course, is a long-standing colleague. Wonderful talk, thank you. My question is undoubtedly, our federal government is shameful in its lack of action, but our state governments are doing a bit. And on a report card, if the report card was for state governments, maybe we wouldn't be last in the world. So just hold that one before you comment. And Natalie McGrath also says, I'm interested in your views on the politics of this. How do we create sustainability given the tension with political inaction and even political belligerence, I guess?
Good question. So to address the first one about states and territories, it is the case that all of our states and territories have net zero targets, though most of them are by 2050 with the exception of ACT, so they're still not strong enough. But yes, it is the case that our sub-national governments, our local and state and territory governments are stepping up. And a lot of them are doing really good things. So there are internal scorecards that the Climate Council has done, that WWF has done, that rate the different states against one another to try to get them to compete, to be, you know, the first one to the top. Yes, and so internationally, if we'd been rated on a state-based basis, we probably wouldn't have come last. That was very much a federal assessment. For Natalie's question about the politics, you can't talk about climate change really without talking about politics, because it has become, unfortunately, such a politicized issue. The issue for Australia really is a very practical one, in that we still earn about $30 billion a year or so from coal exports. So the government is clinging to coal for an economic reason, but we've got to look against that as to how much climate change is actually costing us. So our inaction is actually costing us, given that the Black Summer bushfires, as I said, cost $100 billion. So we need to weigh that up. I think the federal government is being held hostage to a few highly conservative people in marginal seats that are coal mining seats. And what we can do about this, well, all of us over the age of 18 have got to vote. And if we could only persuade the Australian people to make climate change policy the #1 reason why they vote for a local candidate, we could change very, very quickly.
Lesley, we're going to wrap this up. There's several more questions come in, and they're mostly about, from Brian Johnson, for example, a great question on the public concern and will that overcome the policy inertia and result in timely action. They're about what we can do in Australia as individuals, and some discussion about studies that might be available. I would just point everyone to the, in the chat, Chrissy has put all the contacts of the MJA report, the Lancet report, and the IPCC report, and many of the answers are in there. If you really get desperate, I'm sure you can email me or Lesley and we could maybe ferret out an answer for you, but most of it is already published and available. I'll draw this to a close, and on behalf of everyone, can I just thank you very much on behalf of the Institute and all those who came in. I think there's a lot more now than 90 have come in, and a number are leaving now to go to their next meeting. Lesley, thank you very much. We've already had you back several times. We need to have you go back to continue our knowledge and our discussion of this, the most vital of issues. So thank you.
Thanks so much, Jeffrey. Pleasure.